Today we're going to be talking about how to write a lab report. In chemistry, a lot of what we do are lab experiments, and like I told you at the beginning of the year, I'm never going to give you a lab unless I want you to learn something from it. And so writing a lab report is the best way to do that. So the best way to prove to a teacher that you have understood the purpose and results of a lab experiment is through a written lab report. There are two types of lab reports to be expected in a science classroom: a formal lab report and an informal lab report. There are several aspects to a written lab report. We're going to talk about all the different aspects, and then later I'll show you a table that tells you which aspects belong in a formal lab report and which ones belong in a informal lab report. So the first thing that you're going to receive points for is the general layout of your lab report. And points in this section are for the overall presentation of the write-up. Next, you have the purpose, and this section details the general reasons for the lab and summarizes how it will be performed. This should only be included in the formal section. Then you have materials and procedure section, which lays out all the materials utilized and gives step-by-step instructions for carrying out the lab. Again, this is only included in the formal write-up. Materials lists should be provided, and any modifications to your procedure need to be made at this time, or noted at this time. Data table, or tables, one of the main sections of the lab. This is where all observations and data should be written and tabulated in clear and labeled tables. So one of the really important things of a lab is that you're taking data, you're recording observations. Sometimes those observations are what we call qualitative observations, which means that they're descriptive. They don't really have set values, but they are important. So for example, if a solution changes color, that would be a qualitative observation, saying that the solution color changed from a clear colorless solution to a pink colorless solution. So that's something that would be written more in paragraph form. But then if you're, say, obtaining the mass of several objects or the volume of several different liquids, those should be in clear labeled tables. The calculations section, and this is the section of the lab report that all of the calculations for your lab should be performed. If you're doing multiple trial sets and you're doing the same calculations for each trial, in the calculation section I only require that you show the work for one full set of calculations. So trial 1, you do all of the calculations associated with that. After that, you can just state the other trial results, calculation results, in like a table form. But you only have to show the full out working for one of your sets of calculations. You do have to do the calculations for all the other ones, you just don't necessarily have to write them all down. Calculations is also where you're going to calculate percent error when it's applicable. Graphs, and this is a section that is only to be used if applicable. Some of our experiments will easily allow themselves to be graphed, some won't. So these are only necessary for if the data is best analyzed or described in graphical form and should be clearly labeled and appropriately sized and made in the appropriate style of graph. And when I say appropriately sized, I mean that if all of your data occurs in less than 1, like your values are all less than 1, your scale should be no greater than 1. Meaning that like your x-axis should go from from 0 to no greater than 1, right? I don't need you to go from 0 to 10 and then have all your data squished together at the beginning. So we'll talk about that when we talk more about making graphs. Error analysis is where you're going to look over your lab and discuss the error found and any percent error that you calculated. Here you need to kind of give me the what happened, why it happened stuff, and how it affected your results. And finally, the conclusion. This is the main part of the lab, showcasing your understanding of the experiment and results. This should always be in complete sentences, and it's a really important part of the lab that tells me whether or not you actually got the concept that I was trying to teach. So the different styles of write-up, you've got the formal and informal. Like I said, the purpose and materials and procedures sections are only required in a formal lab report. Data tables, calculations, graphs, error analysis, and conclusion, Those are all required in both formal and informal. Again, remember that graphs are only required if applicable. So a detailed rubric is going to be seen and shown in the following slides, and you will get a copy at the beginning of class in the next few days, and then attached to every lab write-up that you hand me, I will attach the grading rubric. Each of these sections that we just detailed are then separated out into below standard, at standard, and above standard expectations, and grades will be determined using the rubric with the following formula. So the fact that you turned in a lab report guarantees you 85%, well, sorry, doesn't guarantee 85%. We start at a base of 85%. So if there's the presence of a lab report, you start out at 85%. We're going to subtract 2% times the number of bullet points that you are in the below expectations range for each of your sections. And then we will add 1% for any time you're above standards expectations. And we will subtract 5% times the number of items that are missing, and that'll give you your final percentage. So these are details about what the layout, purpose, and materials and procedures section should look like and should handle. So in the layout, you're going to get what is above standard is there should be a title with question included. The lab report needs to be in the correct order. There's points for general neatness and readability, correct spelling and grammar, and typed text, data, and graph. Now that's above standard. If you wanted to get at standard, you would reach 3 to 4 of those above standard bullets. If you were below standard, you would only reach 0 to 2 of those bullets. So again, I'm not requiring that you type up every lab report. That's just if you want to get above standard. You could perfectly get at standard by having a title with the question included, correct order and general neatness, and correct spelling and grammar. That would get you at standard. That is fine. I do not require typed lab reports. That's just if you want to reach above standard in that point, in that aspect. So for the purpose, you need to have the above standard bullets are a brief statement of the purpose of the lab, an explanation of how the lab will be performed, and a description of what results will be collected. And being at standard meets 2 of those bullets, and being below standard meets only 1 of them. Materials and procedure. So below standard says that there's no mention of materials or the procedure, and there's a vague step-by-step procedure when not otherwise provided. At standard, there's a mention of what materials and procedure were provided without mention of modifications made, and there's a general step-by-step procedure when not otherwise provided. And then above standard has a mention of what materials and procedure were involved, any modification made to the materials and the procedure, and detailed step-by-step procedure with materials when not otherwise provided. Alright, so those are the below standard, at standard, and above standard results for layout, purpose, materials, and procedure. And the layout will be graded with every lab. I'll be giving a general kind of, could I read this? Was it readable? Were there complete sentences? That falls in the correct spelling and grammar section is complete sentences. So that falls into layout. But purpose and materials and procedure is only required for a formal lab report. So data tables, calculations, and graphs. Data tables, to be above standard, they need to have a descriptive title, clear column and row labels for the data, units, correct limit of precision and significant figures for data, and detailed qualitative observations included when appropriate. Being at standard meets 3 to 4 of the above standard bullets, and being below standard only meets 0 or 2 of those bullets. So for the calculation section, being at standard says that examples of all calculation types are shown. And when I say all calculation types, I don't mean do the calculations for every trial. Like I said, you don't have to do it for every trial as long as you do a full set for one trial. So all types of calculations being shown means that one full trial of calculations were shown. Calculations and results have the correct limit of precision and significant figures as associated with the data, and there are units included. To be at standard, you reach only 2 of the above standard bullets, and to be below standard, you only reach 0 or 1 of the above standard bullets, or the results don't make sense and no explanation is given as to why. And this is important If the calculations that you're showing don't make sense and you don't give an explanation as to why they don't make sense, then you're going to be below standard. If they don't make sense and you do make an explanation as to why they don't make sense, then that's okay. For graphs to be above standard, you can have a descriptive title, units, axes labels, and it's appropriately scaled. You have the appropriate graph type. A trend line is included for scatter plots, and the appropriate choice of data is applied to the graph. Being at standard for this means that you only meet 3 of the 4 of the above standard bullets, and being below standard means you meet 0 to 2 of the above standard bullets, or your graph makes absolutely no logical sense or is too hard to read. If I can't read the graph, I'm not going to do it. And when I say too hard to read, this is what I was talking about earlier with the scale. When you scale it too large and you have all your data points grouped at the very beginning and then you have all this excess room over at the side, that's too hard to read or it doesn't make sense. All right, finally, error analysis and conclusion. So for these sections, to be above standard, your errors are listed, including the % error when a known value is available. An explanation of how these errors could be prevented in the future needs to be provided, and an explanation, this is the most important, of how your errors affected the data has to be there. Being at standard, you only meet 2 of the above standard bullets, and being below standard, you either don't meet any of those bullets or you only hit 1 of them. And for the conclusion, you should have for it to be above standard, you'll have a brief summary of the experiment, a restatement of the purpose of the lab and how it was or was not met, a conclusive statement about the lab and results, meaning this is what I found, this is what it means. Key data and calculation results are included to support your conclusion. So like I said, with the mystery lab solution, you need to have A and B reacted to show this. And then validity of the results is provided through error analysis or logic. And again, remember, you need to really explain your logic. Don't just say deductive reasoning. That's a nice fancy word, but I don't know what it means to you. So explain to me your results. Being at standard meets only 4 of those bullets, and being below standard meets 0 to 3 of the above standard bullets. Alright, we'll be talking about this a little bit in class, but again, you'll be given a rubric to look through, and that rubric will be used with each individual lab report that you write, and I will clearly indicate what you were or were not meeting on that rubric for the lab. So, have a good night, guys.